So welcome to the next video of this playlist in which we will are going to start scientific notation. First of all, we will see its definition. Numbers are expressed in a standard form called scientific notation, which implies powers of 10. The internationally accepted practice is that there should be only one zero digit left of the decimal. Thus, the number 134.7 should be written as 1.347 exponent 2. When we write this number in scientific notation, we will write point after the first digit is first non-zero digit decimal. Then we will write the power of this 10. 10 have power 2 because right after the this decimal point 7 we have two numbers 3 and 4. So 1.347 implies power of 2. Similarly, 0.003 should be expressed as 2.3 exponent minus 3 because when we will write this in scientific notation, we will write 2.3 and 4 point. There are 3 digits before this point 2. So we will imply the power 3 because we are starting from left, so we'll have negative in the power. Conventions for indicating units. Now we will see conventions for indicating units. Use of SI units requires special care, more particularly in writing prefixes. Following care should be kept in mind while writing units. Full name of the unit does not begin with a capital letter even if it is named after a scientist, Newton. For example, unit force, Newton is a unit of force. So we will when we will write this is named after a scientist. When we will write, we do not start it with a capital letter. The next one is the symbol of unit named after a scientist has initial capital letter such as N for Newton. For example, when we will write unit of force is Newton, we will not always write complete name Newton. We will symbolize it with capital N. So capital N will always show the unit of Newton and it will be written as always capital. Next one is the prefix should be written before the unit without any space, such as 1 exponent minus 3 is written as 1 millimeter because 1 millimeter is equal to 1 over 10 raised to the power 3 meter. Combination of base units is written each with one space apart. For example, Newton meter is a unit of work or equal to joule. For example, work is equal to F dot D. Force have a unit of Newton and D or distance or displacement having a unit meter. When we write both these multiples or product of F dot D, we will write with the one space apart. Next one is compound prefixes are not allowed. For example, 1 microfarad. We will not write this as double micro. We will write 1 picofarad. 1 micro equal to 10 raised to the power minus 6. When we multiply this, it becomes pico. We will see this in this chart. A number of such as 5 exponent 4 centimeter may be expressed in scientific notation as 5 exponent 2 meter because the number should be always in SI units or the SI base units. Meter is a base unit, so we'll write this always centimeter in the SI base unit. When a multiple of a base unit is raised to the power applies to the whole multiple and not the base unit alone. For example, 1 kilometer is equal to 1000 meter. So when we will put this 10 raised to the power 3 over here, then whole square of this kilometer will be done, like 10 raised to the power 3, it will become 10 raised to the power 6, and similarly meter will also become meter square. Next one is measurement in practical work should be recorded immediately in most conventional convenient unit. For example, micrometer, screw gauge in millimeter, and mass calorimeter in gram. These are the standard units for these instruments, but before calculation of the result they should be converted to appropriate SI base units. This is the sum. This is a table of some prefixes for powers of 10 like atto, femto, pico, nano, micro, milli, centi, deci, deca, kilo, mega, giga, tera, peta, hexa. So these are the symbols of these uh, prefixes, and these are their factors. So these are all important MCQs. We will continue from next video with errors and uncertainties.